So moving on to match the column type section, we have question number 56, which says that a shop sells 6 different flavors of ice cream. A customer chooses 4 identical cones filled with flavored ice cream in n different ways. Condition in which the selection is made is given in column 1 over here, and the values of n are given in column 2 over here. We have to match the column 1 with suitable entries in the column 2. So let us discuss A part in column 1. The question says that they are of different flavors. Students, we have 6 flavors of ice cream to be filled in 4 cones. Okay. So for A part, the question says that they are all of different flavors. So out of the available 6 flavors, you just have to select 4 flavors. 6C4. Since the cones are identical, the number of ways of filling the cones with different type of flavors is equal to 1. Okay. So 6C4 into 1, that means 15. Talking about B part says that they all are not necessary of different flavors. That means the question is asking you, they may be of different flavors, they may not be of different flavors. That means the question is asking you the total possible number of ways of filling the cones. So if we select 4 flavors, then what is the answer? It is already written above, 6C4 into 1, that is 15. If we select any 3 flavors out of 6, then we will select in 6C3 ways. Now we have selected 3 flavors. Out of these 3 flavors, 1 flavor will be filled in 2 cones. So for selecting that particular flavor, we have 3C1 ways. That means 6C3 is 20, 3C1 is 3, 60 ways. For 2 flavors, select 2 flavors out of 6 flavors, 6C2 ways. Now for 2 flavors, there are 3 possibilities. First possibility, first flavor in 3 cones, second flavor in 1 cone. Second possibility, each of the flavor in 2 cones. Third possibility, first flavor in 1 cone, second flavor in 3 cones. So into 3. 6C2 is 15 into 3, 45. Only 1 flavor. So select only 1 flavor and fill it with only 1 possible way. That is equal to 6. What is the total number of possibilities? 126. So B part, the answer is 126. For C part, they contain exactly 3 different flavors. So 60 is the answer for C part. And for D part, they contain either 2 or 3 different flavors. So 3 plus 2, that is 60 plus 45 is equal to 105 is the answer for D part. Now let us match the entries of column 1 with column 2. A matches with, the answer is 15. So it matches with only T. B matches with, the answer is 126, Q and S. C matches with, the answer is 60, R, S and T. And D matches with P and T. Okay, so this is the final matching. Let us move on to 57. Question number 57 talks about the inequalities or equations in X are given in the column 1 and column 2 contains different values of X. Match the inequalities or equations in column 1 with the values of X in column 2 which satisfy that particular inequation or equation. Okay, so first is a logarithmic inequality. We have log of minus 4 into x square minus 3x plus 2. That is the base. Number is modulus of 4x minus 5 greater than 0. From here you will get one condition is that base is positive. Second condition is that base is not equal to 1. And third condition is that number is positive. Number is modulus, so it has to be positive. Only one element will be excluded, x not equal to 5 by 4. The last condition will be after solving the inequality, the base is always less than 1. So we'll have modulus of 4x minus 5 less than 1. The inequality will be reversed. Raised to power 0 is 1. So we have from here x belonging to 1 to 2. From here we have x not equal to 3 by 2. From here we have minus 1 less than 4x minus 5 less than 1. So 4 less than 4x less than 6. X belongs to 1 to 3 by 2. The final answer for domain is x belongs to 1 to 3 by 2 minus this value, that is 5 by 4. So we have to choose the suitable options. Obviously, it is very clear that RST lies outside this interval. P is a value which is slightly greater than 1, so A matches with P. Also, Q is a value which is just greater than 1, Q also. So A matches with PQ. Okay, let us do B part. For B part, we have modulus of x minus 1 plus modulus of x minus 4 less than equal to 3. We know that the range of modulus of x minus a plus modulus of x minus b is modulus of b minus a to infinity. So if a is 1 here and b is 4 here, so the range of this LHS is 3 to infinity. The inequality is saying that it is less than equal to 3. So that means LHS has to be equal to 3. So if this is equal to 3, x belongs to the closed interval a to b. So 1 to 4 is the answer for closed interval. P matches, Q matches, R matches, as well as S matches. So B matches with PQRS. Okay. Every value of x lying between 1 to 4, this particular function mod of x minus 1 plus mod of x minus 4 takes the constant value of 3. Okay. Let us move on to C part. C part says that fourth root of mod of x minus 3 raised to power x plus 1 is equal to cube root of mod of x minus 3 raised to power x minus 2. So the statement reads mod of x minus 3 raised to power x plus 1 by 4 is equal to mod of x minus 3 raised to power x minus 2 by 3. Students, we have to carefully analyze all the possibilities of the solution of this particular equation. The first possibility is that modulus of x minus 3 is equal to 1, because 1 raised to power any real number is equal to 1 and left hand side will be equal to right hand side. Second possibility, mod of x minus 3 is equal to 0. 0 raised to power any non-zero number is definitely equal to 0. Again, both LHS and RHS will be equal. Third part, bases are already equal. So if the powers are equal, then also we have a solution. So x plus 1 by 4 is equal to x minus 2 by 3. From here you will get x is equal to 2 or x is equal to 4. From here you will get x is equal to 3. From here you will get x is equal to 11. So we have 2, 3, 11, R, S, T as the correct choices. Okay, for C part. Let us move on to D part. D part says that 3 raised to power x plus 1 minus modulus of 3 power x minus 1 is equal to 2 log of mod of 6 minus x to the base 5. We'll have to consider two cases for 3 raised to power x minus 1 non-negative and for 3 raised to power x minus 1 negative. From here I have x is greater than 0 non-negative. From here I have x as negative. Okay. So for the first case, if x is non-negative, what will happen? If x is non-negative, I'll get 3 power x plus 1 minus 3 power x plus 1 is equal to 2 log of mod of 6 minus x to the base 5. So we have mod of x minus 6 is equal to 5. From here x has two values, x equals 1 and x equals 11. Further, if x is negative, then the modulus will open with reverse sign. 3 power x plus 1 plus 3 power x minus 1 is equal to 2 log of mod of 6 minus x, which is equal to mod of x minus 6 to the base 5. So this is log of mod of x minus 6 to the base 5 is equal to 3 power x. Students, if x is negative, 3 power x is less than 1. So the right hand side is less than 1. If x is negative, the left hand side is always greater than 1. So we have no solution from here. So if x is positive, two solutions, x equal to 1, x equal to 11. If x is negative, no solution. Ultimate solution set contains two elements. According to the options given in column 2, I have only T as the correct match for D part. Okay. Let us move on to next section now, which contains integer type problems.